very quickly. Welcome. This is our Math 1332 hybrid class. This is October the 6th. I'm starting on the screen to remind everybody that every Saturday you should go look in MyLab Math, the announcements, and see the assignments for this week. And then make a plan. The plan, it's got to be for you. Like I'm going to do all my stuff on Saturday and be done with it. It could be that you're going to break it out a section on Monday and a section on Tuesday. But just make a plan and then give plenty of space and time for those hours. And have backup plans and try to make it fun if you can. Around here, we share the Wi-Fi space, and then we try to take walks. We sit on the front porch. We may try to go to a coffee shop and just try to do something different to be able to keep going and get the stuff done, because we're now basically in the middle of the semester. And to me, this is the hardest part. At the first, you're kind of excited, and at the end, you're kind of geared up to get your finals done. It's just that middle is hard. So really work to be intentional about your studies. In this class, last week we did a mini lecture, and I had lots of favorable response in the mini lecture, but then also that the breakouts were important. So we're going to balance them, and the balance is going to look like this. Sorry about the highlighting. It looks very hideous on the screen, but the first thing we're going to do is look at lesson 8A and lesson 8B. So this is the time for you to pull out your lessons. I staple mine together. So like here's 8A and then 8B. So go ahead and get your ebook open. Go ahead and scroll down to lesson 8A. Go ahead and make sure you got out your calculator and everything, just like you're walking into class. And we're going to start with 8A, and I'm going to do a mini lecture on that. So not that, that's next. So I'm going to pause the recording and check on my live people. So I am going to do a little mini lecture on 8A. I look at what is assigned for the week and try to look at some of the harder stuff, because I think looking at the videos that I've already put into the assignments list, the easier stuff should be easier. And maybe it's going to be good to point out some of the harder stuff and you hear it in person, or if you're not here, you'll hear it on the recording. And so looking at 8A, I just want to point out some things. It's titled More Water, Please. And as you're looking through it, you're going to see all sorts of representations like a chart and a graph. And so this class is called a non-algebraic class, but yet we touch on some algebra. And this is some of the algebra we touch on. And if we were face-to-face or even in the chat right now, when we hit the algebra, sometimes students are like, thank goodness we finally made it to algebra. And some other people are like, really? Can we just skip this and go back to what we were doing? Either way, we can make this different and hopefully very understandable. And so the things I want to tell you that you need to memorize are things like this. And so I put the y equals mx plus b up here, and you'll hear me talking more in depth about this on the videos, but I just want to point out again some highlights and some mini lecture. And so when you see this, this is a slope intercept, specifically the y-intercept equation. And so we keep it pretty straightforward and nice in this class, but you got to know a couple of things by memory and then know when to use them. And so if somebody says we have a slope, which that's the m, and if somebody says we have a y-intercept, put it in an equation, all you got to do is plug in the two pieces into that equation and you're done. It's literally that simple. So I'm going to highly encourage you on the test to draw pictures. I grade pictures, I grade words, I grade question marks and scribbles. Maybe not the question marks, but here is an example like if a repair person came to your house and if that person charged $75 just for driving up to your house. And so this over on the y-axis, we're going to call the cost. And just for driving up to your house, they've spent no time in your house, but just for driving up, they're going to charge you $75. That $75 is 0 hours, but there's a cost. And that's our y-intercept because it's intercepting running through the y-axis. And so that is our y-intercept. And in just a minute, I'm going to put that number right there in place of the b. But then come to find out, for every hour that this person stays at your house working on whatever it is they are fixing, they're going to charge you $50. So if we started at $75 for driving up, another $50 would be about $125. At 2 hours, that would be at about $175. And about 3 hours, that's going to be at about $225. And so I know I look like I've got a curve going in here, but y'all ought to be trying to write on this turf column. You would have a curve too, maybe not. This is supposed to be, and if it gets crooked, I just move my dots. It is supposed to be a line. It's a linear equation. And linear, if you look at the first 4 letters, spells a line. And so looking at this equation, if somebody said a repairman drives up and they charge $75 when they drive up and $50 for every hour, can you write an equation for that? Sure. The amount that's being changed is $50 for every 1 hour. And that $50 for every 1 hour is our slope. So 50 times x plus the $75 starting cost. So that's just a real quick example. That's something that's coming to you in lesson 8A, where we're talking about a slope-intercept equation and just a real quick made-up example. I don't see any questions in the chat. I'll go ahead and do this next part, and then I'll stop in case people want to ask questions, or you can unmute and ask right now. But there's a second thing I need you to have memorized, because sometimes they give us different information and we got to find different ways to get the slope. If they hand us the slope and say, yeah, the repair person drove up and they charged you $75 for no hours, well, there's your y-intercept. Well, that was pretty simple. The next one was pretty simple too, because for every hour they're there, they're charging you $50. Well, that's your slope. Well, that one was pretty nice too. But that doesn't always happen to be the case. It could be that somebody says, here's some temperature, and here's some ice cream bars, ice cream. And so over here can be the temperature, and it can be like, I'll put a little break in my graph here, 90, 95, 100 degrees, our temperature in Fahrenheit. And somebody tells us that at 90 degrees, you're selling 40 ice cream pieces, and at 95 degrees, the person in the store was selling 60 ice cream pieces. So 10, 20, 30, 40, 50, 60. So over here at 90, we were selling 40, and at 95, we were selling 60. And so somewhere in here, it could appear that this is linear, and we can do a whole lot of things with it, but all I wanted to do right now was to put those into our slope formula, because the problem could be, find the slope from the given information. Okay, I'm just going to start labeling x1, y1, x2, and y2. Then I'm going to go plug them in. For y2, I'm going to go down here and grab the 60. And then for y1, I'm going to go grab the 40. For x2, I'm going to grab 95. And then 90 for the x1, and I'm going to get 20 divided by 5, or 4. And you'll hear me say a lot on the videos, keep slope in 2 parts. I know over here I've got it as a 50, but in reality it's a 50 over 1, $50 for every 1 hour. Well, over here it's 4 somethings for every 1 something. And so I want to go back over here and say that slope is delta y. Is what's coming in delta? I think delta is the hurricane coming in. Delta y over delta x. Somebody can agree or not with that one. I don't remember. So delta y over delta x means the change in y over change in x. Well, the y thing that we have going on is the ice cream. So we got ice cream in the numerator because it's the y. And then the x is the temperature. And so the other thing that you get asked in our section is write a contextual sentence. So in this case, we would say, we're going to sell 4 ice cream pieces, bars, whatever they are, for every 1 degree our temperature increases. I like to start at the bottom and say for every 1 degree we go up, we're going to go up 4 ice cream sales. So I'm going to stop the video when I get it to let me know it hears me. So I checked in with our live people, and they were good on what we were just talking about. And so now you see very brightly on the screen, we got lesson 8A. That's what I just hit some highlights on, and you've got the full video in your announcements in My Lab Math. Now lesson 8D, number 6. And so I'm not going to do all of this lesson. I'm going to hit the part that's usually the most confusing. So again, I'm in 8B as in boy, and I'm looking at question number 6. So it's your job to go back and watch the entire video, because I go through everything, and you can start and stop as much or as little as you want to, but there is a concept. What it's doing is it's kind of expanding what we did in 8A, telling it to you in a different situation and using a decrease instead of an increase. And then it goes over and says, hey, there's this new concept, and it's called proportionality. So I want to read just a little bit to you that says, there are lots of ways to say if something is proportional or not. And if you're looking at question 6 on the screen, it says, examine the proportionality of these 2 equations. Y'all, this is a perfect test question. That's not a wink, wink that this is what's on there, but this is a perfect question where I can change out the numbers and just leave something like this for the test. And so this thing called proportionality, we can do it the fancy pants way, we can do it lots of different ways, but here's the one that students usually just say, I like that version the best. And so here it is. And you might want to go back and watch this video and jot this down, or jot this down now. If the line passes through the origin, the linear relationship is proportional. So if the line passes through the origin, it is proportional. Otherwise, the linear relationship is not proportional. So either it is or it is not. And so the 2 that you see on the screen, let's see if I can get this to work. The 2 that you see on the screen, we have the y equals 2x plus 3 and y equals 2x. So I'm going to go ahead and pause the recording, because I'd love to hear from my live humans for just a second. So we talked just a little bit, and with our live people, I got a bunch of shoulder shrugs, so I'll go ahead and start right here and say that one of our students said this one is going to be proportional. And the reason they said that is they said because our B is 0. So if you have a graph and something and a line cuts through the origin, oh, that was bad. We'll make that line go lower. If it cuts through the origin is 0, 0. In other words, this is your x and this is your y. And so in our y equals mx plus b, that means it would be y equals mx plus 0. In other words, there ain't nothing back here. And so the student said, this one is 2x plus nothing, therefore it went through the origin, therefore it's proportional. Yes, that student's exactly right. And then I asked about this one, because it's going to be just the opposite of it. This is y equals mx plus b, and is the b 0? And if the b ain't 0, this one is not proportional. I will have a question like this on the test, and I will say, is this equation proportional? Yes or no, tell me why. And so you can say yes or no based on the 0, and then you got to tell me why. And you can say one of the big fancy explanations that are in your lesson, or you can simply say it does not go through the origin, or it does go through the origin, and that's it. And so I'm done, finished with this mini lesson. I'm going to ask my live people if it'll work. Come on, you can do it. X, move. Oh, here, let me get rid of that. So I'm about to send y'all to a group. And when I send y'all to a group, and it's who doesn't mind being recorded, I don't know so much about that. It'll depend on how much time. But discuss in your groups, you're only going to get like 3 minutes, and then I'll call you back, and then I'll make a 4th minute. What made sense to you about proportionality, and what was still or is still or was confusing to you about proportionality. And so let me look at the rooms because I always mess up one of the rooms. Okay, I'm okay. All y'all are going to do is go meet somebody, say hi. You can tell them your major. That's always good. But then say what was confusing about proportionality and what was good about proportionality, what keywords, I don't know, what made it stick in your brain or what still has it confusing in your brain. So you've only got like a really short 3-ish, 4-ish minutes. Y'all go talk to somebody and I'll see you back in a minute. So we just had a really good discussion. The participants here, the class people, they gave out some examples of past classes. They gave out some examples of kind of what they're seeing going on here. And one student said, in proportional, the slope looks pretty. And so the scribble you see on the screen, I came up here and I made a chart for the proportional one. I made a chart for this y equals 2x. And then I made another chart for the y equals 2x plus 3. And after I made the chart, I stacked my y over x, my y over x, my y over x, and they came out gorgeous. Just a 2, a 2, and a 2. That's proportional. So when you do this on a test, you can make a chart and you can stack the y's over x's and say, look, they all came out perfectly. They're all proportional. They have the same proportion. Or you can look at them as we did earlier and say, well, it's going to go through the origin. It's proportional. Or you can look at this other one and look at how I stacked them up. The y over x was a half, then it was -1, then it was 5, then it was 3.5. Anyway, definitely not the same proportion. Or you can just say it's not going through the origin, hence it's not proportional. So I'm going to erase all of this, and we're going to go to our next mini lecture when I can get all of this to work. There we go. And so now we're going to look at lesson 8C, and we're going to look at part 3E. So my live people, my listening later people, would you go to 8C, and would you look with me? Oh, excuse me, I need some more coffee. My Keurig is messing up today. I already cleaned it, worked on it, but it's still messing up. So I had my daughter go to Starbucks, and that costs like money. I got some caffeine, evidently not enough. So y'all are with me on lesson 8C, and you're looking with me at 3E. On this mini lecture, we're going to do an example, and then I'm going to send you to groups to do your own example. And so looking here throughout this whole lesson, again, what we're doing right here is MINI lecture mini. It's teeny, teeny, tiny. I've made videos for you guys where I've cut and paste all of these ideas, and I talk through all the ideas, and I write on the screen, and you can start and stop the video as many times as you need to make it make sense. But at the top of, maybe not the top of your page, but at question number 2, in 8C, it says, suppose you want to invest $1,000 in savings and it's an account that pays 2% interest, and it's annual interest, and you're going to compute it, and then what all are you going to have at the end of the year? So here's part of my mini lecture of lesson 8C. So I'm grabbing a whiteboard, and when I grab the whiteboard, you're going to end up with a couple of thoughts and equations going on in this lesson. And one of them is that you're going to have simple interest. And when you talk about the simple interest, it needs to really make sense to you. And I would go ahead and memorize the formula that you're going to have principal times the rate times the time, and then you're just going to add it back to the principal. You're done. That's simple interest. But I don't want to talk about simple interest today. I want to talk about compound. And on the compound, we're going to get an equation that starts with an A, an accrued amount, P for the principal, 1 plus the rate, and send it up to the T power. Again, this is a quickie little mini lesson, and I just want to show you some of the harder parts that when I've been face-to-face, my students are like, wait, what? And so here we are, and I'm looking at question number 3E. I'm in lesson 8C. And then the question E says, use your equation. Here's our equation, this one right here. We're going to use our equation on 3E. And it says to determine the amount of money in the account after 30 years. And so you need to go back up to the first part of question 2, and they're going to tell us some stuff in question 2. They're going to tell us the amount we invested was $1,000. They're going to tell us that the rate was 2%. And then this question tells us that we're going to leave it in for 30 years. So they're asking us using compound interest, not simple on this one. And that's where you have to go watch the whole video to know which section we're in. I just wanted to pull this one out. Compound interest, a formula, plugging and chugging. There will be a question like this and the simple one on the test, but I wanted to do the harder one for our mini lecture. So here's what I'll be looking for on the test. I always think it's important for students to rewrite the formula. I would memorize this formula. I think I actually end up putting it on the test, but I would go ahead and memorize it. And I think if you use it enough, you'll memorize it. But the accrued amount is going to be, so in place of principal, we're going to put the $1,000. So what do you show on the test? I would show the formula. I would then show the pieces that I'm putting in, but there's a little quirk about the rate. You got to put it in as a decimal. And this is where I usually have students mess up. The decimal on the 2% is right there. And when you go to convert to a percent, 100 has 2 zeros, or the percent sign has 2 zeros. You got to move over 2 decimal places. So I'm not going to put 2% over here. I'm going to put 0.02 to represent the decimal value of 2%. And then T stands for time. So that's where I'm going to put my 30 years. So I need everybody to grab a calculator. I don't want you to grab your cell phone. You're hurting yourself if you don't use the calculator you're going to use on the test. And cell phones are not permitted on the test. TI graphers are not permitted on the test. So I've got just a plain old calculator. And I go through this probably more slowly in the video, but here's a quick run at it. You need to find a, it's the reason I require a scientific in our class. You need to find a button that looks like, let's see what this one has. This one has the caret, and that's the button that I'm going to punch to make it go up to 30. Some of y'all may have this button. Some of you may have a button like this. Those are the only two coming to mind right now. Let me pause just a second and ask my live people if they see their button. So we just went through this whole problem and I didn't have it on record, so I'll go through it again. You got the formula A equals P parentheses 1 plus R to the T power. P stands for principal, 1 stands for the actual whole number out of the principal, which is what we play with on the recording, plus the rate, and send it to the time. And so the question is, if you have $1,000 to invest at 2% for 30 years, what's going to be your accrued amount at the end? So when you go to take the test, I highly encourage you to write down the whole formula. This A equals P parentheses 1 plus R to the T. I think I put it on the test, but I'd go ahead and memorize it. And then I want to see you plug in the parts, like plug in 1,000 for P, and then parentheses 1 plus 0.02. And this 2%, you don't put it in as a 2, you put it in as the decimal value up to the 30. Then when we started punching this in, I like to go backwards, but you can straight punch it, use parentheses, do not use a grapher, do not use your cell phone, use a scientific. And so here's what I'm going to do. I like to go backwards. I like to try to really make sure the calculator's hearing what I'm saying. So take time to go ahead and hit clear a bunch on your calculator and go ahead and type in 1 plus 0.02 and hit equals. Then you're going to have to find your exponent button. It's either like a caret button like this one, or it's like y to the x, or you might need to Google and find out what it is on your certain calculator. But on mine, it's this caret button. So I punch caret 30 and then I hit equals. So I send it up to the 30 and I hit equals. I'm not going to keep writing stuff down because if I do, I'm rounding, I'm getting further off from the correct answer, plus it just takes extra time. So I've done the 1, the plus, the 0.02, the up to the 30. Now all I've got left to do is times 1,000 and hit equals. And when I do, I'm coming up with 1,811 dot and then round to the nearest hundredth, which is 36 cents. So now I'm going to send our live people off to do this on their own, but first I need to pause. So I'm back, and this was the question I sent my live students off to go answer, and it's wrong that I've got too much on there. I asked them to go grab the 3,005% and the 8 years, and they all came back with this answer. So the accrued amount would be the $3,000 times 1 plus the 0.05, send it up to the 8, and they said it came out to be about $4,432.37. So on a test, you would need to, not everybody's going to want to write the formula, but you need to write the part where you fill in the formula. And then you need to give me the about number, and you need to give me a $sign and round it to the hundredth. I did write this one down wrong. I want to go ahead and give you a sneak peek of what's to come. And it looks something like this. This one said compounded quarterly. So the cool thing is we're going to take the formula that we already know, and this is not to be memorized. I'll put this one on the test. And it's principal 1 plus the rate divided by some number and the time times that same number. And you're like, wait, that's basically what we just did. You're right. And so to finish this question in full, and by the way, you can go ahead and jot this down. You can go ahead and get it in your notes. You can go ahead and be typing it in your calculators, but at least let me get it written down. The principal is the same with the 3,000. The 1 plus is the same. The 0.05 is the same. The 8 in the time is the same. The n is the only thing different, and you got to come right here to compounded quarterly. And so you're asking yourself, in a year, how many times would quarterly be? And that's 4, and it would go in the denominator, and 4 would go over here. And that's it. And then you've got to practice punching this, and let me check the time. We can do it. I'm going to start inside of here and work my way out. And so y'all can go at it your way. I'm going to unmute when I get done and see what kind of answers y'all are getting. But I'm going to start in the middle if you want to follow me. And I'm going to go 0.05 divided by 4 equals. Then I'm going to add the 1 in and hit equals. I'm going to send both of those up, not to 8 times 4. I'm going to send both of those up to 32 because I don't want to add any more keystrokes than what I have to. And then I'm going to hit equals. I'm going to do times 3,000 and hit equals. And we're going to get that now, compounded quarterly, our accrued amount is about, well, anybody want to unmute and tell me? We are recording. I don't care if you do. Anybody? And that's a nobody. So here we go. We got a 4,000 I'm getting. Y'all check my work. $4,464.39. Can anybody here give me a thumbs up or a thumb? Oh, I like it. I got 1 thumbs up. Well, I'll take it. 2 thumbs ups. Okay, we'll take that too. So I'm going to quit recording. No, I'm not. I'm going to go ahead and show you on the next screen, because on the next screen is part of, oh, come on, let me change screens. There we go. Just talking about the things for you to use, the resources, and those have been in the sessions before. But this is the one I wanted to get to. My question for you earlier was, what do you think is different about high school and college? And so my live people, I am still recording, but I wanted y'all to see this screen. A colleague of mine made it. And on your chat, I would like you to leave me by telling, what do you think's the same about high school and college? And so I'm going to stop the recording, and y'all can continue to email me and talk to me throughout the week, but I'll definitely see you next Tuesday, and a lot through email between now and then.